So today in this session, we are going to discuss 3 tutorials. I hope we can finish these 3 tutorials in 50 minutes so that I can record 3 videos for these 3 tutorials. Okay, I will start with tutorial 2.3. Let me read the questions first. Okay. The equivalent circuit of the figure below, okay, the equivalent circuit of this figure shows an ideal transformer. This is ideal transformer. As you can see, primary side and secondary side of the transformer, where clearly in the secondary side you can also see the leakage impedances R2 and X2. Okay. So at the secondary of this transformer, it has R2 plus JX2, which is 1 plus J4 ohms of the leakage impedances. The turns ratio of this transformer is 5 to 1. Okay, turns ratio is 5 at the primary to 1 at the secondary. Question is, draw an equivalent circuit with the series impedance referred to the primary side. So the first one, you need to draw the equivalent circuit with the series impedance referring to the primary side. Series impedance meaning that these R2 and X2. Okay, these are the series impedance. Okay, referring to the primary side. So we are going to transfer this impedance to primary side. This secondary impedances to primary side. Just like that, right? And B, for a primary voltage of 120 volt RMS and a short connected across the terminals of A, B, calculate the primary current and the current flowing in the short. Okay, at the secondary, dengan primary voltage ni kita berikan dia sebanyak 120 volt. Okay, kita connect this transformer at the primary with 120 volt. Okay, so this is step down transformer. Dan kita shortkan A dengan B, terminal A, B. Sepatutnya kita letak load kan? Tapi kita shortkan. Which is something about short circuit test. Okay. Something similar to the short circuit test, which is we join the load terminals together. We connect load terminals, we short it to do calculation, short circuit current. Okay, so we are going to draw the equivalent circuit and then answer B. So in B, we want to calculate the primary current and the current flowing in the short. Okay, so I will start with A, which is, as you can see on my right hand side, as usual, you will see the drawing canvas that I'm sharing with you. I would like to start with drawing again the equivalent circuit, because this one is impedance at the secondary side, all right? So I'm going to draw the equivalent circuit that is already referred to the primary side. Okay, that is clear. And this is terminal A and terminal B, right? And we have also, it doesn't mention on my left hand side or primary side itu, is it what sort of terminals, but basically we have some input voltage V1, okay, and it allows the current I1 to flow. And remember the dot convention, for the transformer that from that dot convention, we can determine the direction of voltage and current at the primary and at the secondary. All right. So just write down all of the variable. So basically we have here in the question R2 and X2. So when we refer to primary side, whether we want to use R1 and X1, or also we can just use R2 prime and also X2 prime. That means prime means it has already referred to the other side. Let's say this R2 and R2, I represent it by using Z, which is the impedances at the secondary side, right? So I want to refer this impedance to the primary side. So this guy Z referred to the impedance at the primary. So I'm going to use a label, different label from Z here. So this is Z prime basically. So this is actually Z prime. But for R and X itu, saya nak gunakan, this is R2 that has been referred, R2 prime. And the other one is X2 prime, which has been referred to the primary side. Okay. But Z prime is actually R2 prime plus JX2 prime. That's it. So we have the turns ratio also given, N1 and N2. And basically for N1 divided by N2, this is the step down transformer. So given that N1 divided by N2 is 5 divided by 1. Okay, so step down transformer. So the number of turns at the primary is greater than the number of turns at the secondary. Right. So just follow the formula, which is, we can say that the secondary impedance here is referred to the primary side of the transformer by the turns ratio, which is the turns ratio is 5 to 1. That turns ratio A is 5, right? Okay, the turns ratio clearly is given here, which is 5. So this Z is referred to become Z prime 5 times greater. Can you get it? Okay. So maknanya sebelah high voltage semuanya lebih besar sebanyak 5 kali ganda. Sebelah high voltage semua values lebih besar sebanyak 5 kali ganda. Alright. Kecuali current current dia terbalik kan. Kalau transformer ratio itu, transformer equivalent circuit, ideal transformer equivalent circuit, the rule is voltage primary to voltage secondary equals to number of turns primary to number of turns secondary equals to current at the secondary divided by current at the primary. Okay. So basically what we do here is to just use the formula, which is Z prime here is A square Z, right? So Z prime is R2 prime plus J X2 prime. A square is 5 square. Z is R2 plus J X2. Okay. And then calculate, substitute. Yang ni saya nak buat N1 by N2 square lah. Senang. Okay. R2. Berapa R2 diberi? Dalam soalan, R2 is 1, X2 is 4. Okay. R2 is 1 plus J 4. Okay. So, directly calculate this. Which is we have 25 plus 25 darab 4, 100 kan. Plus J 100. This is R2 prime plus J X2 prime. Ataupun this is Z prime lah. Okay. So Z prime, which is this Z prime is R2 prime plus JX2 prime. So R2 prime is 25. X2 prime is 100. Just write that. And actually you can just redraw this. Ataupun just substitute the values given here. Saya tak buat kat situ. Substitute the values. That we have calculated. Okay, B. We want to find the current at AB terminal when we short the AB terminal. Okay, for a primary voltage of 120 volt, 120 volt has been applied and short connected across the terminal AB. Calculate the primary current flowing in the short. Okay, so let me just redraw a bit more. So we have the equivalent circuit like that. Now, I put a conductor lah. Saya letakkan conductor. I short it. Saya letakkan conductor warna merah ni. Basically, this is not resistor. This is just a conductor to short the terminal A and B. Terminal A and B, saya shortkan. So that at that time, what happened? Current, which is current I2, will be flowing. Saya namakan current itu sebagai I2 lah. Because this is V2. V2, of course lah, bila kita short, V2 ini adalah 0 lah. Bila kita short, V2 adalah 0. And I2, we can expect that a very large current. Because short, bila kita short, semua current tu sebanyak mana yang boleh dia akan pergi ke ground lah. Dia akan pergi ke ground. Ataupun dalam kes ni dia akan, so terminal yang bawah ni sebenarnya connected to the ground lah. Alright. So kita nak cari current ni. Current ni berapa? Given the question also V1 is 120 volt RMS. Okay. And yang impedances ni, impedances yang tadi lah Z prime. Saya just letakkan Z prime. Ataupun saya masukkan teruslah value dia 25 plus J 100. Okay. So all of those information are given in the question. What we are going to do is to find the current, short circuit current at the secondary side. So we just use the formula. As usual, we will start with the ratio of current, primary and secondary current. I1 if divided by I2, it is equals to A. So we turn it the other way around. Sorry, I1 by I2 is 1 over A, right? So if we want to get I2, let me just turn it I2 divided by I1, which is A lah. Okay, right. Betulkan sikit lagi. This is A. Okay, so next step is we know that at the primary side, I1 is V1 by Z prime. We have Z prime at the primary side. So we just calculate I1 dulu. Kita calculate I1 dulu lah sebab kita nak substitute dalam equation ini. So just substitute all of the information given in the question, which is V1 120 divided by Z prime. Okay, so for this particular calculation, I hope you can do, because this is just using the normal calculus. You can just need to write, this is 25 minus J100, right? And 25 minus J100. Kalau tak faham tu kena back to the calculus lah. Oops, saya nak delete ni ya. J100. So kita darabkan dua-dua numerator and denominator. So that saya short circuit lah sikit. Okay, 625 tambah, if you do the calculation, just tekan the calculator saja. So if I have done some wrong, if I've done something wrong, just let me know. Okay, 10,000 kat sini. Okay, so yang tengah-tengah tu akan cancel lah. Then we get only real numbers here. We'll get only the real numbers. Oh sorry, yang 10,000 tu sebenarnya J kan? Cuma saya shortcut tu lah. Okay, yang bawah, yang atas yang bawah, yang atas. 120. Yang ni yang bawah kan. Sekejap, saya kena cut sikit Saya kena cut sikit. So yang ni yang bawah 25 darab 25 625. Betul. Okay, saya kena adjust sikit Okay, I will do it like this. Yang atas 25 120 3000. 3000 tolak J 12,000 betul? Salah bagi tahu Okey, yang bawah yang tu cancel. Tinggal lagi yang ni tambah yang ni So we'll do it like this. 3000 untuk yang bawah dulu 3000 minus 12,000. Itu kekalkan. Kita tulis balik yang bawah. Plus 10,000 is 10 6 to 5. And 6 to 5. Okay. So for this one, what we need to do is to further calculate. I will just straightly calculate this. We want to get the magnitude. So this is I1 in the form of real and imaginary numbers. Okay, so we want to get the magnitude. Finally, you will get from this calculation, you get 0.28 minus J 1.13 ampere prime S lah. Then we want to get it magnitudes, magnitude of I. Okay, simply we can just use this. Everything about maths, I hope that you all know how to do it. So otherwise we need to keep practice. Okay, seterusnya. Dua, tujuh. Dan sambungan. Sebenarnya saya punya borderline tu. Ini saya punya borderline. Untuk bila saya convert ke PDF, saya perlu ada satu borderline kat situ. Kenapa dah boleh zoom lagi? Alright. So next, just continue. We get 3553 1.3553 square root which is the answer is 1.16 ampere RMS magnitude of I1. That is I1. Okay. So dalam soalan kita nak I2. Simply what you can do is I2 by I1 is A. Okay. Yang mana A itu adalah 5. Gantikan A darab dengan I1. Okay. So simply you get 5.8 lah. 5.8 ampere RMS. The current at the secondary side. So the current at the primary side is 1.16. Current at the secondary side is larger, which is 5.8. Tak sama macam voltage sebab the idea is to maintain, to make sure that the power can be kept constant. Power at the primary will be kept constant. Power is V times I, right? So you want to make V times I itu constant, whether it's primary or secondary, conservation of energy or power. So that is why current, bila voltage drop, current akan naik. Okay, that is for the first question, which is tutorial 2.3. Okay, so I will stop recording to continue with second question.